Okay, I'll do questions 5 and 6 from paper 1. Okay, let f of x equal this, point lies on the curve, normal to the curve, I gotta do differentiation, is parallel to this, find the value of k. Right, if f of x is k x to the power 4, the derivative is 4k x to the power 3. Okay, normal to the curve has this. Okay, at the point 1k. So at P, the gradient of the tangent is f prime of 1, which is 4k times 1 cubed, which is 4k. Therefore, the gradient of the normal is a negative reciprocal of that. It's negative 1 on 4k. But the gradient of the normal, it's parallel to this. So then, therefore, the gradient of the normal is this gradient, minus 1 over 8. So get rid of the minus 1s, that means 4k equals 8, that means k equals 2. That's your answer. The secret is looking at the word normal, knowing that the gradient of the normal is this, gradient of a normal makes you think gradient of a tangent, makes you think differentiation, done. Okay, log question. Adding logs means multiply. So log to base 2 of x times x minus 2 equals 3. Okay, if we add the logs, we've got to multiply the arguments. Right, rewriting that, that means x minus 2 equals 2 to the power 3. We change it from log form to exponent form. Multiply it out, we get x squared minus 2x equals 8. Rewrite it, x squared minus 2x minus 8 equals 0. To solve for that, we have to factorize x minus 4, x plus 2, and solving gives us x equals 4 or x equals minus 2, but x is greater than 2, therefore x equals 4 is the only answer. We have time for one more. Okay, inverse function. If f of x equals log to base 3 of square root of x, show that the inverse function is 3 to the power 2x. Inverse function. Okay, f of x was y equals log to base 3 of square root of x. The inverse function means x equals log to base 3 of the square root of y. Okay. The square root is to the power of a half. When you have log to the power, you can bring the power out the front. Therefore 2x equals log to base 3 of y. Now we've got a basic log form, so we write it in exponent form. Y equals 3 to the power 2x, and that's our inverse function. I have shown that. Okay. What's the range of the inverse function? Well, the range of the inverse function for something like this, in simple exponential function, range has to be y is greater than 0. And it's all real numbers greater than 0. which makes sense according to that. Okay, very quickly, C says find the value of the composite function inverse f composed with g of 2. We can write that better, inverse f of g of 2. G of 2, well, g of x was up here, log to base 3 of x is log to base 3 of 2. So if we put that in this function, replace the x with this, therefore the inverse function g of 2 equals 3 to the power 2 log 3 on 2. Same as we've done before, we can do the reverse. This will become a power. So 3 equals base log 3, 2 to the power 2. 3 to the power log base 3 cancels itself out. So the answer is 2 to the power 2, which is of course 4. Okay, so the answer there is 4.